How do you classify substances? How to find out if something is ionic, polar, or non-polar? Firstly, let's talk about ionic compounds. Just as the name, ions. What are ions? Ions are something that has a positive or negative charge. For example, whenever you see metal plus non-metal, it is always an ion. Remember that. Or another easy tip to say if something is ionic is if you see a metal in any of the compound names, then it is an ion. Now, for example, NaCl, that is sodium chloride, or CaO, calcium oxide. Here, Na is the metal, Ca is the metal. These both are metals and it is included in a compound. Thus, these both are ionic compounds. Now, why are they called ionic compounds? Because between two of these metals, the ions are transferred, not shared. It's transferred, not shared. Shared means if there are two, that means both of them will be sharing. That is, calcium will be taking one, oxygen will be taking one. Transfer means if calcium has two and oxygen has one, calcium will transfer two of these to oxygen. So this is how you identify if something is an ionic compound or not. So whenever there's a metal present, it's ionic. Now what about polar and non-polar? So if in a compound, both of the elements are non-elements or non-metals, and if no metal is present in that compound, then it is called as a covalent compound. Covalent. Now covalent compound are of two types, and that is where you see polar and non-polar. So keep this in mind. Covalent is broken down into polar and non-polar. So what are polar compounds? Polar compounds means unequal sharing of electrons. This happens when some atoms pull electrons with different strengths. For example, let's take H2O. So in this, oxygen is more electronegative. Electronegative means it has the power to pull more electrons to itself than hydrogen. So if hydrogen has 2 electrons and if oxygen has 6 electrons, oxygen has greater power to attract these 2 electrons towards itself. Thus, this is called as electronegative. So, how is this polar? Well, almost all polar compounds have these 4 elements in them, or any of these 4. And an easy trick to memorize this is with the abbreviation phone call. Phone call is FONCL. That is fluorine, oxygen, nitrogen, and chlorine. So whenever you see these elements, this phone call, that means that compound is polar. Let's see. H2O, NH3 or ammonia, HCl. All of these has N, O and Cl. If any of the elements from phone call is found in any compound, then that is polar compounds. And then finally comes non-polar. So what are non-polar compounds? Non-polar compounds is where equal sharing happens. Polar compounds are where it is not equally shared and one element will be attracting electrons towards itself. Whereas in non-polar, both the elements or the same atoms will be equally sharing the electrons amongst themselves. For example, O2, N2, CH4. So the first thing you need to check is whether there is a metal and a non-metal. If there is no metal and non-metal, then we can cross out the idea of an ionic compound. Then you check if whether any of the elements phone call is present. Okay, now this is where most students will confuse. You might tell, oh, there's oxygen, there's nitrogen, and isn't that a polar compound? Well, no. If oxygen and nitrogen had some other element along with it, then it will be polar. See over here, NH3. Here N is not alone, N has H with it. So N can attract the electrons from H. That's why it is polar. But here N is alone with again another N. So both the electrons are shared. Here O is with another O. Both the electrons are shared. Now over here, have a look. CH4. Now you might be thinking, how is CH4 polar? Okay, so in CH4, there are two types of bondings. There are CC bondings as well as CH bondings. CC bondings are completely non-polar. That means CC bondings have same amount of electrons shared between them, so they are non-polar. Now coming to CH, or CH will be having slightly polar in the sense extremely small polarity. That means we can take it as a negligible amount. So we take CH negligible. So that's when we come to the conclusion where CH4 or any hydrocarbons are non-polar. Now talking about hydrocarbons, what about cyclohexane? What is the formula for cyclohexane? C6H12. Cyclohexane, C6H12. Over here again, CC bonds, that is non-polar. And there will be also CH bonds. CH bonds are slightly polar, or we cancel it out because it is negligible. So CH, that is cyclohexane, is also non-polar, or all hydrocarbons are non-polar. This is how you find out if whether a substance or a compound is non-polar, polar, or ionic. Let's go ahead with a little bit of questions. Let's go ahead with these questions, starting with KCl. So the first thing you might be thinking is, oh, there's a Cl in this, so we use phone call. So that means it is definitely a polar compound. Are you right? You're absolutely wrong. Why? Because look at this carefully. KCl. You split this up. K is a metal and Cl is a non-metal. So when both metal and non-metal, or if alone a metal is there in a compound, that means it is an ionic compound. Always remember that. Now if you're thinking how do you guess or how do you know if something is a metal or not, it's from the periodic table. You need to know the periodic table for this. Nextly, HCl. So here, now you can use the idea of phone call. Cl comes here and Cl attracts the electrons from hydrogen, and thus it is polar. Next, C3H8. What is C3H8? Yes, it is a compound, but it is a hydrocarbon. And whenever hydrocarbon comes in any questions, then it is non-polar. And if they ask why is it non-polar? Because CC bonds, as I said, CC bonds are non-polar and CH bonds are slightly polar or almost negligible. Thus, we take it as non-polar. Now, the final question is H2O. Is this polar, non-polar, or ionic? Well, the actual reason is that H2O is partially polar. Why do we tell that H2O is partially polar? Why is it partially polar? H2O is partially polar because when you learn more about the periodic table, you will find that oxygen is the most electronegative element in the periodic table. And hydrogen is very, or the smallest atom, right? And oxygen is extremely stronger than hydrogen. Thus, we can conclude that oxygen pulls maximum of its electrons, but it only, ends up with a few electrons because hydrogen only have a few electrons. Thus, we can tell that there is not complete polarity, it is just partially polar. And this is how you classify substances from this idea. And if this video helped you to understand this concept clearly, please like and subscribe to the video and follow for more.